Now we're going to use concentration as a conversion factor. What do I mean by that? Well, let's say they give you the percent. They say, all right, you have a 10% sodium chloride solution. You have, let's say, 255 grams of that solution. How many grams of sodium chloride are there? So in these types of problems, they give you the percent, and then they give you one other piece of information, and then you have to find the third. So let's take a look at what you're supposed to do. Let's say you have 255 grams of a 10% sodium chloride mass over mass solution. So it's 10% by mass. How many grams of sodium chloride are there in it? Okay, so that's one way it could be worded. So they've given you the grams of solution. So this is the grams of solution. And this is the percent. Now, I always tell my students, the first thing you want to do, if they give you a percent, immediately put units on it. Get rid of this percent sign and put units on it so you know how to use it as a conversion factor. So instead of writing 10% and you know it's mass by mass, you write 10.0 grams of sodium chloride. Like if you get 10% on an exam, that's 10 out of 100. So 10%, not that you'd ever get 10% on an exam. 10% sodium chloride by mass is 10 grams of sodium chloride per 100 grams of solution. So in order to get rid of that percent sign, you always put it per 100 grams. Now you have units on your percent. What did they give us? They gave us 255 grams of solution. So now it's pretty straightforward. I'm going to just go ahead and use a different color here. Actually, I'll use blue. I'm going to write, okay, 255 grams of solution. I'm going to use this as a conversion factor. Can you see that grams of solution will cancel out with grams of solution if you put it down here? So this is going to work out nice and easy. 10.0 grams of sodium chloride per 100 grams of solution. So grams of solution will cancel out with grams of solution. I could probably do this in my head. This would be 2.55, and then times that, it would be 25.5 grams. So there's a decimal here, grams of sodium chloride. So in 255 grams of solution, of this 10% sodium chloride solution, you have 25.5 grams of sodium chloride. You can double check the math. You just go 255 times 10 divided by 100, 255 times 10 divided by 100, and you get 25.5 grams of sodium chloride. So what were the steps that we just did for this problem? Number one, we put units on the percent. Number two, we took the other number that they gave us. We put that right up front. We wrote its units, and then we used our percent to convert. So we set it up so that the grams of solution will cancel out with grams of solution. All right, let's try another one. Let's say I told you that you've got 12 grams of sodium chloride. Okay, you've got 12 grams of sodium chloride, and you've created a in the 10, let's make it a bit more difficult, in the 15% sodium chloride aqueous solution. So my question is, how many grams of solution do you have? Now this is a mass by mass also. So they've given us the grams of solute. They've given us the percent. We just don't know how much solution we have. So first thing you want to do right away is put units on the percent. So we're going to write 15.0 grams of sodium chloride per 100 grams of solution. All right, so we do that. Then we leave it alone. Then we get the other number. The other number is this 12 grams of sodium chloride. So we're going to write down 12.0 grams of sodium chloride. I need this to be used as a conversion factor. So basically what I want to do is I want to cancel out grams of sodium chloride. The only way I'm going to be able to cancel out grams of sodium chloride is if I flip it. So you take this and flip it over. So you have your 15.0 grams of sodium chloride down here and your 100 grams of solution up here. All right, let the units guide you. All right, don't just blindly put it up this way just because we did that in the previous problem. Previous problem, we didn't do it blindly. We wanted to cancel out grams of solution, so we had to set it up this way. But here you want to cancel out grams of sodium chloride. You flip it, you cancel. I'm going to need my calculator for this. 12 times 100 divided by 15. So 12 times 100 divided by 15, and I get 80. I think that's what I'm saying. That's 80. So since I want 3 sig figs, I've got 80.0 grams of solution. Okay? All right, now let's make it a little trickier. Sometimes they're not looking for solution, they're not looking for solute, they're looking for solvent. So this is where it gets a little tricky. All right, let me show you. How many grams of water are in 225 grams of a 7.00% sodium chloride aqueous solution, right? So this is the scenario. I'm asking for grams of water. I'm not asking for grams of sodium chloride. I'm not asking for grams of solution. This is a little different. So first things first, what did I tell you to do? Put units on your percent. Put units on your percent concentration. So I'm going to write 7.00 grams of sodium chloride per 100 grams of solution. That's what you do right away. You put units on your percent. This is going to help you a lot if you're actually paying attention. So always put units on the percent. Okay, what do we have? We have 225 grams of solution, because that's what the problem said. We have 225 grams of solution. So very good. If we use it this way, we're going to end up with grams of sodium chloride at the end. If we take this as a conversion factor, yeah, great, we'll cancel out grams of solution, but we're not going to end up with grams of water. So this is where I tell my students you need to tweak the conversion factor. Okay? So before we use this conversion factor, we need to tweak it so that we have the units that we're looking for. Okay, we want to keep this 100 grams of solution. We want the solution because we want to cancel it. What we want to do is we want to change this here and turn it into water. Now this is an aqueous solution, so we know that the solution is water and sodium chloride. I'm saying, based on this, that in 100 grams of solution, I have 7 grams of sodium chloride. So that means the rest is water. You see what I'm talking about here? In 100 grams of solution, 7 of them sodium chloride. So 93, 100 minus 7 is water. So that's what you do. You go 100 minus 7 is 93. So instead of using this as a conversion factor, you're going to say 93.0 grams of water are in 100 grams of solution. Do you guys see what I did? This is how you're able to tweak a conversion factor to get you the units that you're looking for. So now I can just use this one beautifully right over here. I'm going to write 93.0 grams of water per 100 grams of solution. Look, grams of solution cancel with grams of solution. And what units are you ending up with? Grams of water, which is exactly what we want. Remember, dimensional analysis, just like we learned at the beginning of the semester, is a beautiful tool to get you the units that you want. So you set it up, you cancel the units, and we pick up our calculator to see what our actual number is here. So 225 times 93 divided by 100, and we've got 209.25. I'm going to just round it to 3 sig figs. So that's 209 grams of water. Okay, so when they say how many grams of water are in 225 grams of a 7% sodium chloride aqueous solution, you have 209 grams of water. Okay, and that's how you use percent as a conversion factor. I gave you 3 different examples. Hopefully this will be enough. I mean, normally I might give more, but I think in the next video we'll switch over to using molarity as a conversion factor. Okay.